Hey guys, Mr. Callan here, and I'm posting this video to help you with your assignment for Wednesday, Thursday. The assignment will be available today, which is Wednesday, but you can do it today or tomorrow, or you can wait for a Zoom meeting, whatever you find to be more up your alley. So uh, I'm going to start off with this first problem. And this is more of a question that was going to be at the end of the lesson if we did it in class. What are some of the differences and similarities that we see between these two equations? These two types of equations are often misunderstood by students. There's misconceptions. Some students think they're the same, and for good reason. They look very similar to each other, right? They both got 4, they both got 8, 40, and an x, right? The big difference is the parentheses, which we know from order of operations that parentheses can make a big change in what you actually do in the problem. Here, it means we add these two things first. Over here, it's not there, so we need to multiply these two things first. So there definitely is a difference there. And what I want to look at here first is I want to look at the two differences of their tape diagrams, which I think is revealing. And then after we look at the difference of their tape diagrams, I think that'll help you see why these two different equations really are not the same. All right, so let's start with the one on the left. It says that we have a total of 40, as you can see by the number by itself. Actually, let's go ahead and let's do that for both of them. So this one also has a total of 40. All right, now the one on the left has 4 x's and a single 8 added together. So a single 8, like if this was half, this would be 20, quarter would be 10, so 8 would be right about here. And then the remaining length of that distance is going to be split up into 4 equal amounts, which we don't know, but we're going to call x. So we're going to split this up into 4 equal sections and call them all x. Boom, boom, and boom. All right, now over here, this is a different story. This one on the right has 4 groups of x plus 8s. So 4 equal groups would be straight from the get-go, splitting this up into 4 equal parts. And every one of those parts inside is an expression of x plus 8, x plus 8, x plus 8, x plus 8, and so on and so forth. So 4 of those. So you can see the difference in the tape diagrams. That kind of helps you see how these two equations are different. And the big thing for this lesson is being able to find what the x is equal for these equations. All right, so and reasoning through it with the tape diagram, not necessarily having a strategy where we show work, but just reasoning through it. So the reasoning that I would make on this one on the left was, well, if this whole thing's 40 and I take this 8 away, that means that this remaining section from here to here that has these 4 x's is the same as 40 take away 8. So that's like saying this section right here is 32 in length. It's like saying 32 is equal to 4 times something, right? Which leads me to believe I can just take 32 and split up by 4, right? 4 equal pieces, and 32 divided by 4 is 8. So I know that x equals 8 in this scenario over here by just some reasoning, knocking off some distances, and doing some simple division. Now, on this other side, my reasoning would be a little bit different because I don't have that single number that I can just knock off and say, okay, that's gone. This is 32 in length. I can't really do that here. The numbers are mixed together with the variables. So what I do is I don't think of this as individual pieces that I can knock off. I think of this as more, I've got 4 equal pieces to start. So let's go ahead and split. If this is 40 is how long 4 of these things is, then one of these things, just one of them, this green part would equal 40 divided by 4, right? If I took 40 and split it up into 4 equal parts, right? 10, 20, 30, 40, then that means that every one of these is 10 long, right? So 40 divided by 4 is equal to x plus 8, or 10 is equal to x plus 8. And I know that x would have to be 2 in that scenario to make that true. So x is 2, for this equation. I reasoned through it with my tape diagram. And over here on the other side, x turned out to be 8. So they look similar to each other, but they have different solutions. That's kind of the theme of these two different types of equations and tape diagrams that we can represent them with. And the last thing I want to finish with on this video is a couple of word problems where we go through that same idea. Okay, so we're taking a word problem, we're drawing the tape diagram, we're writing an equation that matches it, and then solving and getting our answer. So it's kind of a process, all right? So we practiced this earlier in the week, taking the story and making the diagram. We did some of these at the beginning of the year too. All right. So we've got this family that's traveling to the beach for vacation. Yes. And their destination is 620 miles away before they even begin driving. That tells me right there I'm probably going to have 620 as a total, right? That feels like a total number. We'll see if that changes. So far, they have covered 240 of the total miles, right? So they've already knocked out 240 of these. That's making me feel like, all right, it's a pretty good chunk of the trip, right? So we're going to take off 240 of them there. While at a rest area, the dad makes the comment, I'd like to make it there in 5 hours from now. So 5 hours, driving at a rate of miles per hour. That would be like 5 sections of unknown speed, right? So I'm feeling like I need to take this leftover space and split it up into 1, 2, 3, 4, 5 equal sections of unknown speed, which I will call x, that will land me at my 620 when I'm done. So you see how you can just read the problem, and as you go, if you have your tape diagram set up, you should be able to make sense of it. It really does help to know what your x represents. X is my speed, or also known as miles I'm traveling every hour, right? If I'm going 50 miles per hour, that's 50, 100, 150, 200, 250. 250 plus that doesn't equal 620. So I'm going to have to go far faster than 50 miles per hour to get there, right? So we have it set up where we can solve this bad boy. Now, this would match the equation, the algebraic equation of having the number 240 added to these 5 x's that we have here, plus 5 x's, and give us a total of 620, which is a pretty simple equation that you probably solved when you were in 6th grade. But we're going to reason through it instead of solving it old school. We're going to reason through this. So what we're going to do is we're going to take 240 away from 620, right? So some simple subtraction there. Sorry, wrong number there. 240, not 540. All right, if I take this away, I have to do a little borrowing action, right? So think of that as a 12 now. So 12 minus 4 is 8, and 5 minus 2 is 3. So they got 380 miles to go, and the dad wants to get there in 5 hours, right? So this distance right here from there to there is 380 miles to go. And we want to split that up into 5 equal driving hours. So you got it. It's just simple division from that point, right? 5 will go into this 7 times, difference of 3. And it will go into that 6 times. So 5 times 6 is 30. So dad's going to have to either break the speed limit laws and go over 70, which a lot of your dads probably do. I don't condone it, but I'd say it probably happens a lot. But it's possible. They could get there in 5 hours, and bar they don't hit a traffic jam or something crazy like that. 76 miles per hour is doable in a car without being too dangerous, I guess. Let's finish this up with the last one over here. 5 students came for after-school tutoring. All right, actually, let me go ahead. We're going to draw a tape diagram for this one, so I'm going to go ahead and set it up before I read it. It'll take me a second, but this one I didn't have made out for me. We'll just have to roll with the punches, all right? 5 students came for after-school tutoring. Lynn's teacher assigned each of them the same number of problems to complete. Then he assigned each student 2 more problems to do. 30 problems were assigned in all, so that in all is kind of a giveaway that 30 is my total, right? Now, of those 30 problems, they are divided amongst 5 students equally. And those are words that I can get right here. He assigned each of them the same number of problems, and there's 5 of them. So that lets me know I'm going to split this up into 5 equal sections, right? Think of this as student 1, 2, 3, 4, and 5. Everybody gets the same amount of problems, right? Nobody's getting special treatment. We don't know how many problems they get at the get-go, right? So X can be our number of problems variable, right? So everybody gets X. You get an X. You get an X. You get an X. I'm like Oprah giving out cars, but it's X's. It's not as exciting or fun. But everybody gets an X, right? And then the teacher comes along and is like, oh, you know what? I don't like you guys that much. I'm gonna give you 2 more problems. Or maybe they were getting done too soon, right? So he's like, I'm gonna add 2 problems to everybody. He assigns each student 2 more. So giving them more being the key word there is addition, right? 2 more for you, 2 more for you. You get 2 more problems. You get 2 more problems. Everybody happens to. It's not a one-time deal, right? It's not a single 2 that's going to be in our tape diagram. This is our setup for this problem. It would match the algebraic equation of having 5 groups of x plus 2's. Okay, 1, 2, 3, 4, 5. 5 groups of x plus 2, and that total would be 30. This would be the equation that matches that tape diagram. Now, if I'm reasoning my way through this, I want to know what 1x is worth, and I could care less about all these 5. I really want to pinpoint just one of these. Well, one of those groups is a fifth of the whole thing. So if I take 30 and I split it up into 5 equal parts, that should be equal to just one of those groups of x plus 2, right? Because this section right here is a fifth. Think of this as first student, right? Second student, third student, fourth, fifth. So if I split it up into 5 parts, what's left over should just be one of those sections, x plus 2. And 30 divided by 5 is 6. So it's really easy to reason through this and see that x needs to be 4 because, oops, I wrote equals there when I meant to write plus, because 4 plus 2 is 6. So I know that in the beginning, x is 4, every student got 4 problems. And then the teacher was like, okay, that's not enough. I'm going to give everybody 2 more. So eventually, everybody got 6, right? 4 plus 2 is 6. 6 for you, 6 for you, 6 for you, 6 for you. And that makes sense because 6 times 5 is 30, which that also matches our 30 divided by 5 is 6. So it all kind of connects together, all right? And those are the things that I need you to be able to do. Read story problems, set up tape diagrams, reason through them, match them to equations. Those are the things that we're trying to get together this week. The nice thing is there's no negatives or crazy hard numbers in these problems. I'm keeping it pretty simple with whole numbers. So nothing should be throwing you off too bad. So if you have trouble, as always, give me an email and I'll get back to you as soon as I can. But otherwise, hopefully this video will help you get through the assignment for Wednesday, Thursday. And if you can't get them done, come to the Zoom. We'll do them together. See ya.